We are always on the move, walking, running, cycling. We have the technology that guides us, the freedom to move thanks to our devices which always know where we are and how to get to a destination. But are we too dependent, blinded, or even endangered by this guidance?
To understand what it means to move and navigate, we interviewed a group of runners and cyclists. We found that in these fast-paced activities, navigation needs are more profound. The critical issue of accessing navigation information stood out. While devices help, they can also be limiting, cause disruption in the activity, and present potential safety issues. We are not truly free.
We explored possible navigation support solutions that are minimally intrusive and more natural for these fast-paced activities. We studied how people navigate without technology support. We found that people look around to examine various path options they have and decide which path to follow. Taking this into account, we created RunAhead, a system that combines the natural head movement with audio or haptic feedback to give navigation support.
RunAhead provides turn-by-turn directions at each intersection where the user has to decide between multiple path options. It is based on the definition of a circle around each intersection that corresponds to the user's decision-making area. Every path option is enclosed by an angle range and categorized as good if it leads to the user's destination or bad otherwise. When the user enters the circle, our system activates the head scanning mechanism that implicitly tracks his gaze through his head movement. According to the path the user is looking at, our system gives positive or negative feedback. Feedback can be given modulating the volume of the music the user is listening to, or through personalized haptic or audio cues.
We built the first RunAhead prototype with a head detection custom device using Arduino. This device is connected wirelessly to a phone also carried by the user. The mobile phone app, developed using processing software, takes care of location tracking, data storage and processing, and of providing the auditory or haptic feedback. The prototype is worn on the head and gives feedback depending on the direction you are looking at.
RunAhead will ultimately be reduced to a chip that could be integrated into earphones or a device that can be clipped on headbands, helmets, or glasses.
We tested the usability of our system with runners, and we are now beginning to test it with cyclists. We will continue to develop it because we believe that RunAhead gives people more freedom to move.